Welcome back everyone. In this lesson we are going to learn about the Brents method. Although we are not diving into the details of this method, we are just using it to introduce you to a more advanced method which incorporates some of the benefits from the open methods and some of the benefits from the bracketing method. So it's an hybrid approach. So we are going to introduce you to this method which can be used in your thesis or practical problems that you are going to follow in your later semesters. So let's look at this. So if you remember, the benefit of bracketing method is that in the bracketing method you are ensured that you will find a root. That means the reliability of bracketing method is much more than the open methods, because in the open method we are not using any boundary. As a result, it is not ensured, or it is not you are not confident that you will find a root. You will get the method to be converged at some point. So that's the case that open methods are less reliable than the bracketing methods. But the another benefit of open method is that the open methods are faster than the bracketing methods, and that's what we are going to use in Brents method. We are going to incorporate all the benefits from both of these approaches. That means we are going to combine the reliability of bracketing method and the speed of the open methods, and that's the main theme of Brents method. So what Brents approach is that we always use the speedy open method wherever possible. That means either we can use the second method or the Newton-Raphson method, and in some cases wherever it is necessary we will use the bracketing method. So throughout the whole procedure, at all locations we are going to use the speedy open method, but at some crucial points, at some complex root finding locations, we are going to use the bracketing method. So what we are seeing here, that there is no separate method, rather there is a combination of each of the bracketing and open methods. So this method was developed by Richard Brent and Theodore Decker in 1973 and 1969. Theodore Decker discovered this method earlier in 1969, and based on his approach, Richard Brent modified the whole algorithm. So that's why it is known as the Brents method. So in the case of Brents method, we are going to use two open methods and one bracketing methods. The open methods are second method and the inverse quadratic interpolation method that we have covered in the previous two lessons. And for the bracketing method we are using the bisection method. So this Brents method is a combination of all of these three methods. So the general idea is that whenever possible we are going to use the speedy open methods, one of the open methods like second method or the inverse quadratic interpolation method. But whenever throughout the calculation, whenever the result is unacceptable, we revert back to the bisection method. So bisection method, since bisection method ensures the finding of a root, and that's why whenever the results are unacceptable we revert back to the bisection method. Otherwise we use one of the open methods. The reason behind using the bracketing method, that the bracketing method bisection method ensures that you will get a root within the bracket, and that's why we are using this Brents method. Otherwise it might happen that if we only used the open methods, we might not converge to a true root, and that's why we are using the bracketing method. So one common approach that people use is that they initially use the bracketing methods because bracketing method ensures the root. As a result, whenever during the calculation you get closer to the root, you convert back to the open methods, because at the vicinity of the root the error propagates very slowly. The reduction of the error is very slow. As a result, whenever we are ensured that we are close to the root, we revert back to the open method. So that's another approach that people use. They usually use the bisection method initially, and at the vicinity of the root they revert back to the faster open methods. So the algorithm is very straightforward. We are not providing the details of this algorithm. but we are providing a supplementary PDF book which shows the details of the Brents algorithm. So we are not showing the algorithm here in details, but we want to inform you that in MATLAB there is a function which uses the Brents method and which is known as the F0 function. This F0 function incorporates the Brents method. So if you want to try out the Brents method, you can go to the MATLAB and try out this function. It's very handy. So in this lesson we have learned some of the basics of Brents method, although we did not see any details, algorithm or example of Brents method, because this Brents method is not a new method, rather it's an intelligent approach incorporating all the benefits of open methods and bracketing methods. There are no new approach, no new methods introduced here. That's why we did not go to the details. Brents method is useful for coding purpose. That's why we are going to use the MATLAB code to use the Brents method, and it is not used in hand calculation, as there are 3 separate methods which incorporates a lots of calculation, and that's why Brents method is suitable for your computer coding. So we are going to learn about this Brents method in MATLAB code. So please try out the code that we are given in the attached section of this video. So that's all for the Brents method. In the next lesson we will learn about finding multiple roots. That means all the methods that we have been using in the last few lessons, and the target that there will be one root. That means in one approach, in one try, we are going to find only one root, but there are some methods that through which we are going to find multiple roots, and that is the subject of our discussion in the next lesson. So let's wait for the next lesson, and till then, thank you so much.